Cool. So, good evening, everybody. Thanks for having me. So, I'm going to talk through a couple of AI use cases that myself and my team have delivered for a number of our clients. This will be particularly focused around insurance, but we've done this in legal and other industries. And this basically is how we kind of go about thinking about the problem, and then we'll go into the architecture, we'll break it down a little bit more, and then I'm going to turn you all into a rules engine to help me actually work out what's going on a use case, so to speak. So hopefully it's a bit interactive at the end of the session. Just before we dive in, that bit about me, I work for a company called Cognizant, and I work in their consultancy business and help with AI and that kind of thing. But I've been using AWS since about 2016. You may notice I'm wearing this outfit, so I'm what we call an AWS ambassador, so I kind of represent the company I'm from, but I'm also a SME on the subject, so I have a gold jacket. It's at home, it doesn't fit me that well, but we'll leave it that there. But that's a bit about me. I also got two young daughters that I'm helping to raise. One's 12 now, so she's got a bit of an attitude. So I've got that to deal with. And the other one's 8. They just had all their birthdays, so I just remembering their age. So that's a bit about me, nonetheless. So what is IDP? So as kind of said just a few moments ago, right, documents are still a big source of information. Okay, lying in companies, right? There's forms that come in, there's forms that we interchange between companies, lots of historic information contained in these things. Okay, so when we think about that, it's about using techniques to extract, and then understand what's inside these documents so that we can speed up processing. Historically, a lot of people have sat down, looked at lots of documents, rekeyed information between various systems, and it's quite inefficient. So this is about how we can kind of use AI to kind of aid that process and speed that up. So a couple of examples. This is based on underwriting. So underwriting is the broad process of your company. You may want to insure a big asset, a multi-million pound asset against loss, or you might want to insure yourself against cyber attack, or you may want to insure yourself against somebody like me being your CFO and not your CTO, because I don't do accounts, right? So I'm going to kind of mess that probably up. So you can go to the market, you can kind of ask the insurers to insure you, and then what they do is broker the insurance, because normally of these £1 million contracts, there is too much for one insurer. So they go to the market and basically they offer it out, and you kind of to the rest of the market through the syndicate. To do that, there is these documents that flow in that have all the terms in of what is in the policy, what they want to insure, all that kind of thing, and you have to take it out, understand it, as an underwriter respond to it. Okay, so we help people in that market kind of extract that data faster and understand and pull data from other data sources together. So there's kind of one example where we've done this. We've done this, and we'll talk through some of the tech in a minute. But this is actually quite a few years old. This is before Gen AI. We were using NLP techniques to do most of this back in the day. We have evolved some of our techniques how we do that with Gen AI and other kind of models in the meantime. But it's kind of interesting that kind of we were just touching this space just before the Gen AI boom happened, and this is still one of the main kind of killer use cases. So this is in production, doing hundreds of thousands of documents a year for a client. Second one is pensions and annuities. Okay, so again, in insurance, a couple of insurers we've helped with this kind of solution for. Again, they have lots of different kinds of forms arriving inside their companies that they have to process. So you have, think about pension, you may have it from a couple of sources. Okay, so forms coming from a number of sources. So maybe you're filling it out on their forms in their website, and you can. It's in a pretty good format that you know what you're expecting. Conversely, you may be filling out forms in a kind of someone from a insurance broker kind of person. So they'll be more filling out in forms in their own format and then sending it out to multiple insurers or pension providers in this situation. And then lastly, there is like lawyers. So this is pensions and annuities, right? So not too fine a point on it, the people with these policies will expire. And then you'll have lawyers that will come after to settle the estate of those individuals. So you'll go from unstructured, semi-structured data you know, to semi-structured data you don't know, to in some states just plain text that you have to understand. So in this situation, we've helped develop models that allow them to capture all those different formats, and using various different models to pull that information together to then load it into a number of systems later on in the process. And part of that was tuning specific models in SageMaker. And one last one is very high level. It's like you're saying, and lots of companies have this. Insurance have this. We've seen this in retail. We've seen this in utilities. And this one is actually a utilities example, but it's the same. Is that and this can apply to calls as well. Okay, you call or send emails into a help desk. First thing they have to do is work out where to send it. What's the appropriate person or SME type to send it on to? So this is very simple. Take that unstructured text or that email or that format and just categorize it into, okay, this is in this situation, it's a meter problem, but if it's insurance, it's a fund problem, or if it's in something else, it's a different problem. So we see lots of people kind of want that extraction, but also want analytics over the top of it to understand how many calls or how many emails they're processing. So with this solution, we can also pump it into those kind of layers to provide that kind of intelligence into what's going on. So component-wise, this is conceptual, and we'll go into the AWS stack in a minute, but basically this kind of represents how we think about this, and it's got some key elements, okay? So obviously we've got these various different structures on the left-hand side coming into the system, structured, unstructured, structured, and then it will hit the ML, and we'll use a number of AI services to allow to do that, and there's a couple of ways that we'd explore it. So we'd explore it with notebooks and those kind of things to start with, and then put it through some models and tune some models. So in that layer, we need the ability to run experiments from notebooks, try ideas of how we would use different kind of models to fix the problem, and different techniques to build the problem. Then we have deployment. Mostly in these situations, we're moving either between batch or real time. So as the email hits, setting off in a synchronous process. So we've built things around step functions and integrations that I'll come on to in a minute, where we trigger event-driven architectures, that kind of thing, to process these things. But then other times, like the call center stuff, it may be a batch process that runs and then catalogues this stuff in the background. Key things, and we come on to this, is how we evaluate the performance, and I'll talk to you about that in a few moments, in both when we're developing the models and the techniques, and then when we deploy it, and then putting some validation around it. None of that is not built on solid foundations of security, well architecture principles. Okay, these systems that we are creating are dealing with PCI data, sometimes in real time. They have to be secure. They have to be deployed appropriately. They have to have the right sort of connectivity to other systems. So that's an important element of the stack. And then obviously access to the latest and greatest hardware. So what does that mean like in AWS architecture? So this is kind of how we kind of broke the problem down. So on the left-hand side, we have our ingestion layer. Okay, so that's picking up emails or uploaded scan documents, and basically chucking it in an S3 bucket, storing it securely in an S3 bucket in the right location. we developed this concept of a kind of a case that then hanged all the files together, because if you think an email coming in, it might have multiple attachments, it might have the email body itself providing information in the process, there might be Excels attached to it, there might be PDFs attached to it, there might be Word docs attached to it. So kind of we take all of that around the case and put all that information into, and all those artifacts into S3. That's the first step, and we'll dive a little bit more detail into that in a second. So it's classification extraction, so working out what that document was, so is it a policy document, etc., and then extracting, turning it basically into text that we can deal something with, and then storing that. And then we used the understanding and enrichment layer to add a further dynamic to it. Okay, so and I'll explain this when I turn you into the rules engine, is that there'll be multiple sources of information in multiple documents. So some of this is understanding what's in what one, collating them together, but also identifying where there's repeats, where there may be other candidates, and we'll go through that in a second. And then based on that, do something with it. So on the right hand side, the post-processing layer of, okay, if you want to do analytics, we put it inside a data lake, create dashboards. If you want to do some sort of processing in some workflow system, if it's the underwriting use case, we will put it into the back-end system to do that. And part of this also is that we want to continuously refine the models and tune the models and improve the solution. So we have an element of ground truth and continuous evaluation that allows us to identify where our accuracy is dropping and that we need to fine-tune. Okay, so some of the kind of other services in that LO is Textract, and we're using custom models and Comprehend. So to think about kind of ingestion, this is how we built the ingestion element. We have the Lambda that is pulling from the emails or the scans if it's uploaded by a portal. We're sticking it into something like S3. So you can see it kind of here. And then we do a couple of things with it, okay? So we can then trigger the wider workflow. But before we do that, what we kind of worked out was meta is quite important, and we'll come examples of that in a moment. But okay, so who sent that, when it was created, who was it going to, what was the kind of some of the originating email addresses, that kind of thing. So anything we can glean from the ingestion process, we stick into a DynamoDB table to build up. We're trying to build up data points as we're going to allow us to make an informed decision later on in the process. Okay. Okay, so the next bit is classification. So we used a combination of services to do this. It's not really an architectural flow, this is kind of a functional flow, and some of the complexities that we started getting into when developing a number of these AWS services. Now, in own right, each AWS service is great at what it does, and we've got examples of that in a minute, but there is nuances in how they all input, output, that kind of thing. So to build the extraction process, we had to cope with a number of those. So we'd have the original S3, the original PDF, whatever, in S3. So we want to put that through Textract first. If it was something like Excel, we wouldn't put it through Textract. But if it was something like a Word document, we would actually PDF it to put it through Textract to get a better meaning, because we found that was a better way of capturing Word documents in a more standardized format. So we put that through Textract, and we'd use the raw output of Textract as the next layer. And basically, and we come to examples in that, but Textract has 4 different kind of outputs. And in this situation, what we wanted just to store the raw and use that for the next step to be able to classify it. But we also did table extraction and other bits in the process that for later on. But right now, what we just wanted to understand is, in that PDF, is it a slip or is it an insurance policy? What is it? So we then had to push that into a format that Comprehend wanted. So Comprehend uses a slightly different text format. So we had to do some munging of it in the Lambda there to put it through Comprehend. and it was we developed a multi-label model and classification model to allow us to do that. That produces us a zip file, this one over here. Again, so it's a zip file, so okay, now what we've got to do with that output, how I've run comprehend through it in kind of a semi-batch mode, is take that zip file, unload from that zip file the text file, take the text file out and store that back into DynamoDB for later. So it's kind of, when building solutions, we had to build steps into how to do them to cope with all those different quirks of the different AWS services. So that allowed us to end up with classification of what that document is and the raw text, and then all the other files. So we store all those other like generated files inside the same S3 bucket, and that's how you can see it keeps going back to S3 to keep building and storing stuff around that case. And then in the middle, we're using step functions to build the kind of the process that was triggered by the ingestion process to do the extraction. And so this is examples, like I said, there's a couple of formats. This is maybe a little bit old, but these are the ones we were talking about. So analysing the documents, what's in the documents, then you can have, which is the one we kind of focused on, and then you can have expenses, you can have IDs for driving license, and then you can have kind of lending information, and there's some other derivatives now. But the one we were particularly looking at was to analyse the documents. So we're kind of going to use this example of some AWS invoices to help us understand some of those nuances in a little bit more detail, and turn you guys into my rather intelligent rules engine. So, if you use the document extraction type, this is what you can end up with, right? So you can do queries, you can do forms, you can do tables as well as the raw documents. They turn into various formats, like the table is CSV, etc., that you can pull information. But the raw is just a verbose JSON. Okay, it will tell you word location on the page, which page it's on, in what paragraph, and you have to kind of build up this knowledge of, okay, what's actually located on what page, and that was a kind of a major thing we came up against for this solution. So just to dig into that document analysis in a little bit more detail, you can see it there, okay, you can see you've got bounding boxes of where words are on pages, where they're in tables, where they're in paragraphs, but to go and spot something in all this, you had to apply a degree of logic to it, and then kind of process it. So that's the key thing. The document would be split like a page. If you had a table, this is kind of a good example. If you had a table like that, split over 2 or 3 pages, TextStract would have it at the page level. It wouldn't have it at the table spanning the pages. So you'd have to join the tables back together. And the only reason you can do that was to use the XY coordinate. So we had to build logic in that lambda layer to kind of re-stitch some of the actual data structures back together. So that's where some of the complexity of that format comes in, and some of where we bake stuff into the lambda layer to allow us to do that. So head and footers would throw it off. So you used to have a table like spanning 2 pages, footer in the middle of it. Okay, so it didn't even flow in the same thing. So you had to kind of build it back up. So this is where you guys can help and start helping out in a few moments. So let's think about, if we asked it to extract a billing period, what it's going to come up with. Okay, so there's complexities here of, okay, it's understood. If we ask it for the form, it understands this as a kind of a form format, but it's not giving us the date. It's just giving us this kind of the range. We only know it's a range because we're humans interpreting the range. For the system, it's text. It's not a date format. It's not 2 split out date formats, that kind of thing. And then, but if we do use queries, say, okay, what's the first billing period? It's not then intelligent enough to link the 2. And obviously with LLMs, it's now more intelligent. But when we did TextStract in this area, it didn't have that kind of level of being able to understand that complexity. So if it's in that situation, we then had to develop further intelligence to be able to, okay, that's the billing period. In that situation, we split it out. Likewise, date formats, brilliant. Okay, what month is that statement is?
Depends on country. Sadly, it's not March.
But it could be, couldn't it? How do you know it's not March, and how do you know it's September, and like for like? How do you know that?
AWS is a US company.
Exactly. So how do you know that from this system?
3 days after the end of the billing period.
Yes, but you can't know it from a US company because in your ingestion layer, when you got the email, you could identify that as inbound from Amazon, and by that associate that it's an American address format that they use in all their documents. So that's where you can use the stuff at the start of the process to inform decisions later on in the process. Everybody understand? Cool. So so therefore we built up. Well, table's going to be there, but we then built up what that means. Okay, and using that to understand and extract those data points, and then keep adding to enrichment. So like I said, we can pull out that this was an Amazon address, so therefore we could apply a certain rule, therefore we could capture it. Okay, another example. This is not insurance, and this is just a pure example, but this is a DVLA license form, okay? How do you know, like, okay, who can kind of understand this, but how do you know how these boxes are kind of related? Add provisional driving license. Oh, it's down here. What does that relate to? I want to update my license. Okay. And then so that kind of complexity comes in. Okay, so where it is on the form relating to this is important, right? That gives it context. Otherwise, it's just there. Okay. So again, we need to help the AI to understand stuff. In this situation, what we did was actually create, for examples like this, where we used Hugging Face models. So we then took Hugging Face, it was BERT and equivalents in SageMaker, and we then used examples, labeled examples using ground truth, using custom interface that we built inside ground truth, and labeled up 200 examples of that one use case with significant variation in the forms to be able to understand and extract that information correctly. And then we use that data, and I'll show you a little bit later another example, but then we use that data to then fine-tune the comprehend model also. So that's kind of then using mixed models to very, very focus the accuracy. So beyond that is then understanding it a little bit further and doing other bits and pieces. So, text extract row. Okay, this is the output you get from that bill. Okay, so it's kind of okay. It kind of thinks everything's kind of, it's got reasonable confidence. Okay, billing period. Okay, understands it's a date, so you can use kind of comprehend with your text extract output, understand, okay, it is a date, so maybe in that situation, you could apply some more logic, okay, so you understand it is a date, okay, that kind of thing. So we was able to use some of what comprehend for as a standard model to inform us what the rest of the piece was. So then it's a kind of a too generic, you know, it's 0.7, what is this? Okay, Amazon's an organization, that's the title. We all know that that's an AWS service, don't we? Because we're an AWS event, but the model doesn't understand that. Yeah, and you're coming back with 2 hits with okay accuracy. But if you think that's the answer, you're going to not trust the system because you know it's not the answer, if that makes sense. So confidence in it was key, okay? So how do we go about kind of solving those examples? Okay, so this is how we then took a comprehend model and then kind of fine-tune it using some of that ground truth. Okay, so out the box, and this example, this is now an insurance example. We can see how here it's understanding that there's these terms, okay, and these are liabilities and losses and that kind of thing. So it's understanding for these things that it's 10 million. But the important thing is that it's these are related values. This is kind of the peril, the loss, that kind of thing. So, okay, it's able to pick out that they are amounts, and it's able to pick out that they are and their quantities, and you can use other logic to work out their monetary values. But again, what we're not understanding here is the relationship between that and that. So to do that, what we do is have to fine-tune the comprehend model. So it's a deep learning model, and basically what we're trying to do is then we find the final nodes of the node entities. What we're trying to do is fine-tune the last layer of the neural net to specifically to what we want it to be. Okay. So to do that, basically we gave it examples and trained it on those labeled examples. Okay, in this situation, we would label it up as what we wanted it to be. So we build up those kind of training networks. In this situation, what we did was we trained it on examples of this in our network, 200 examples, and that allowed us to then, okay, when we see this kind of pattern, we know that it's this kind of amount, and that's a PEL and XX, etc., that we could then put through the rest of the system and the different viabilities. And we can see how the confidence is also rocketed because we fine-tuned comprehend. So, last layer. This is where you're going to really work for your money and your beers this evening. Here's some other examples of like differences, right? So these are two different Amazon invoices, but one's with the old logo. So like I said, I've been around a bit, and the new logo. Two different formats. And then you start to get in some of the nuances of how, when you're dealing with these kind of documents, and this is the same with the insurance documents, etc. Things are called different things. Account number, account ID. Are they the same thing? We know they're the same thing. There is that date problem kicking around. What format is the date in? Well, that format's better than that format. Can we understand the date? And then, okay, so what's the total amount? Well, there's a few examples called different things. Is it total due in US? Is that the same for total for this invoice? How is that different than the total amount due? So we get in a situation where there is different candidates, and this is where we start building up the neural network. So here's some other here's another kind of example. Missing data points. So if we're looking for something specific like amount due, where do you get it off of there? It's not on there. So you're specifically looking for something already. It's now not on there. But there's a new term called service provider. That's not on there. How do you know who's the service provider of that invoice? The only reason you know the service provider is because as humans you can understand it. So again, we start building up all this logic in the Lambda to allow us to kind of understand these data points and then vote on which one's appropriate by developing the rule sets that kind of we've been working through. So, oh, that's a date format using additional information and building that back together. So the post-processing process is what we use to do that in. So we stored all that information as we were going along in DynamoDB, and then using a rule set in DynamoDB, we kind of developed these rules that said, okay, if it's the most frequent thing, use that if it's appropriate. If it's the first occurrence, use that. If it's a certain type of date, or if it's date format, use this kind of formatting based on this thing. So we started building up all these rules into DynamoDB to then allow us to push that into and extract those final details into the system. Here's another one. Okay, what's her name? Well, it's all of those, right? So if you're applying for if you've got a policy coming in, it could be in this name. It could be that the email is signed off with this name. It could be that she's married, so maybe the actual insured party is somebody else. So it's with all of that, how do you also know who you're talking about and if it's a different person? So again, we developed to do that. That's where we used existing data. So if there is an email that comes in to the system at the very start, okay, we know where it's coming from, and we use that information, maybe the policy number we extracted at the start, to go to a known truth. So in this sense, we go to the central database that held the customer information for a policy number. Go and look that up. that gave us the name she actually filled in. So that gave us the kind of that solid truth and a high accuracy, because we were pulling it from a golden source. So it's about leveraging these layers and these rules to build up that understanding, and then we use DynamoDB to kind of encode those layers, and that's it. But I hope that's been kind of insightful about how you kind of think about building these AI services together. They're all different formats, and how we had to use combinations of models, combinations of business rules to kind of actually get the actual result.
Awesome.
Questions, I think, is
Yeah, you've got some time for questions. Yeah.
There's got to be some questions, come on. I'm going to go with you first. Have you got a mic or something to run, or are you going to shout?
You want to
Cool.
shout, James?
Yeah,
James, eh?
in the last bit there where you mentioned, you made a reference there to the policy number
Yep.
on RDS. I
Yep.
would assume that's the primary key,
Yeah.
essentially.
Probably.
But then again, how is it, the thing is, it's so, RDS is basically relational.
Yeah.
Okay, how does that relate? How do you translate those primary keys into document stores like DynamoDB? How do they interact, if you know what I mean?
Okay, yeah. So in this situation, if we go back, I'm going to go right back to the start of the architecture, because it's easier to explain. So let's talk through this scenario, okay? So she emails in, right? She wants to renew her policy. These blogs, I think I named her. And she's got a policy number. And she says, okay, I want to renew it next year. Fine. Okay, so from that email, you can kind of, she's got an informal name, but she may have created her policy number. Okay? So use that information, extract it and store it in DynamoDB. So it's just a candidate. Okay, we think it's something there, it's a candidate, it kind of, we can probably work out that it's something reliable. So then we used something like compensate. Okay, that is the account name, because maybe we used something like comprehend to understand that that's what it is. Or we got this whole synonyms thing and enhancement. So we could actually, if we need a format, we could be more confident. We could maybe even regex it and not use AI. Okay, because we know the format. So we know, well, once we identify that, we can say, okay, it's the policy number format. We're pretty confident at this point it's the policy number. Therefore, we also go to the other system, say, okay, we go to our policy system. Now, in that example, it was an RDS system, and it would be probably the primary key, but it doesn't actually matter. If whatever that system is, because it has the golden truth. So you say, okay, I'm confident I've got the policy number, go and get me all the policy details, and that will give you the actual name she originally applied in, and all the other terms of that contract, and that can be then reloaded into the later system. So that's how we're using it, and that's how we'd pull it from those kind of, from like a database or an API or whatever system it could be. Is that cool? There was a question over here somewhere.
Yeah, thank you. So, thanks for the talk. If you think about like including something like multi-caption data, for example, like some of the documents, like for example, it could be from a cluster, or maybe the form is slightly different.
Yeah.
Can you try to use that like in text extract or something?
So that's kind of what kind of TextRact gave us. But it's also what Comprehend also gave us. But that was the essence of the problem, right? You could have multiple, like if you think about an underwriting use case, you would have the same kind of document in hundreds of different formats.
Yeah.
And then using the ML, that's why the ML was powerful, because it could understand those different formats and we could extract it. But then we had to apply another layer on the top of it. To make sure that we were accurate in what we did, what we also used is that end processing layer and the ground truth. And what we did was we developed this kind of we termed it a test harness. So what we did was we took 100 documents of each representative type that we could identify, worked with the client or a number of clients, depending on the use case, and labeled those documents and created them as ground truth versions of all the different variants that we had at the start. Okay? And what we did was we chucked them through the whole solution, not just one layer of the solution, the whole solution, end to end, and see what would come out the other end. And then we would compare what the solution delivered as the final the final answers to those extraction points, etc., and compare that against the gold standard. That allowed us to come up with the F1 score, which was a kind of reflection of accuracy, so that we knew it was that we were improving the accuracy by tweaking all the different logic and all the different models and different rules proactively, selecting different ones. We'd use a different model depending on the different kind of context, different document, that kind of thing. We ran it through multiple, and we've done that multiple times until we got the accuracy, the F1 score, up to where we wanted it to be. And to further support that in time, we used the, when there was low confidence at the end of the process, and it was something that we needed some more work on, we'd identify that as maybe a new variant of document we hadn't seen before, and we needed to then label it more and boost accuracy. Now, we used to do that for 200 documents using NLP. We can use that for about 10 documents using some of the latest Gen AI stuff that we now start putting into the solution. So Gen AI is a lot better because it has a lot more generalization and trained on far more documents, etc. But that's kind of what we did to handle that variation and make sure the accuracy we keep getting was good.
Sorry.
Yep.
Quick question about the example you gave with the amounts due document and the different kinds of definitions of the phrase there.
Yep.
You said you wrote rules to handle that.
Yeah.
So for this specific document, you wrote a rule that says I need to use this specific field, or did you learn in general that this field probably has precedence over that field? Or
so we developed as two separate rules, okay. So when it was named, I'm not sure that's the example, let me go through, it was the one side by side, wasn't it? Or maybe that one, okay. So yeah, there's different things called the same thing. So in that situation, we called them synonyms, and what we would do in the DB would define, once we had detected that variation, at that point we would define a number of synonyms that equal the same thing. So every time we saw something named a count ID, count hash, count number, we knew that those trees, and then we coded that into the DynamoDB, that then the Lambda would apply that rule. So that's how we coped with that kind of variation, the AI, to assist the AI, because they come back with multiple candidates, so we had to select which one. Sometimes we would then, if there was two different candidates, that we would then have to have logic like what came first, or what was more present in the documents, and use that as the example. So we had different rule sets that we could configure in the DynamoDB that would then be applied in the Lambda layer on the subsequent post-processing. Okay. Yes?
I was wondering at the very, very first stage that you got, if you experimented or seen any differences with using an LLM instead of the text extract stage?
Yes. So that's exactly, so you're talking about this stage. Exactly that, right? So this was built a few, it's probably more the extraction stage, isn't it? The classification, so it was this stage. Yeah, so this was built a little bit before, like I said, the Gen AI revolution happened. And we are now using a mix here, okay? So we are using multi-models, and multi-models are really good to pick things up. So now we are using LLMs, multi-model format. And then, oddly, like we're now just sending the pings. Now we're sending the PDFs into JPEGs and pings to send for the LLMs. So that is how we've evolved the architecture over time. We are identifying it. So I may be back at some point telling how we identified this, but we use step functions to do the orchestration. We have played with agents demos in this place, but we're doing some production work on identifying it further. But LLMs have, like I said, are really helping us to further develop this solution.
Awesome.
Oh, I've got another.
Oh, you got another?
Yep.
If you were doing this now,
Yep.
would you start with the LLM, see how far you would get with that, and then do everything with the LLM, would you just...
Yeah, that's a good question. That is good. So the reason why the LLM is potentially more powerful is we can combine these two layers. That's why the LLM is powerful. It gives us the ability to understand, like I said, the images and what's in them due to encoding, etc. and then also provide, due to its own knowledge, etc., some understanding. So we would look to use LLMs more prevalent than this. Maybe fine-tune LLMs, but there's still a case where in certain situations we'd still have to use some of the processing logic to handle some of those elements. So yeah, we do start more or less with LLMs. They're pretty good, but again, where we're finding when it does come to LLMs in that situation, we do spend a lot of time on the prompt and the context in the prompt. And again, to get it to that quality and accuracy bar, we have to spend a lot of time tuning them. So LLMs out of the box will only get you to about 70%. If we want to get to 95% that some of these systems need, we actually have to then really tune the prompts.
Awesome. Thanks, Phil.
Okay. And some of my engineering team are in the audience that helped deliver this, so thank you. You know who you are.
Do you want to put your hands up?
Well, we have Ian at the back, particularly. He done all the cloud formation, all the Terraform, and all the step function stuff at the back of this.
Brilliant. Thank
Cool.
you very much.